Okay, I wanted to spend just a few minutes on talking about sample size again with the central limit theorem. Recall from our last clip that we were talking about this rule of thumb of n greater than or equal to 30, which often is conservative, but it's fair, and it's where we can sort of say we have a large sample and we know two things. We know that our frequency distributions at the sample means were normal at that point, no matter what kind of population we started from. And we know that our sample variance is a good approximator to the true variance, so that we can just do a substitution and say that we know what sigma or sigma squared is. Recall that when we do standardize and we want to use our standard z distributions, what do we do when we standardize? Well, we subtract the mean of the random variable. Here's our random variable here, and we divide by the standard deviation of the random variable. Right? That's the standard deviation, of course, is the square root of the variance, and our variance of the sampling distributions was sigma squared over n, recall. And so here's our z, and notice that we know what sigma is. That's required in order to use the z distribution. We are saying in this case that when n is greater than or equal to 30, we can sort of safely say we know what sigma is. We know what the true standard deviation of the population is. And so this is a constant. This is just a number, right? It's always the same value. So that brings up a question. Well, what happens when we choose a sample that's smaller than 30? Well, let's take each of these points one by one. Do we have normality if we have a sample of size 30 or smaller than 30? Quite possibly yes. It would depend on how our parent population was distributed. For example, if our parent population was, say, distributed roughly kind of bell-shaped or normal, then we would have normality right out of the gate. All of our sampling distributions, all of our frequency distributions of the sample means would be normally distributed. Every single one of these distributions for each sample size, all these sampling distributions of the mean would be normally distributed if we started from a normal parent. So it's not approaching normal. We are normal right from the get-go. So we could very well have a normally distributed frequency distribution of the sample mean for a sample of size considerably less than 30. It's just, it would depend on what this thing looks like, what our population looks like. So this could be, yes, possibly. What about this one? Well, this is the sort of the kicker here, because the n greater or equal to 30 is also saying that we have a good substitute for sigma, but if it's less than, if we stick with this cutoff, again, this rule of thumb is not inherent in the central limit theorem, it's simply just used. We are now saying with a smaller sample we don't have this good estimate, and so when we try to use the z, we can't, because what we end up with is this, where we've now substituted their s for the sigma. Right? The sigma is a constant, but note s is not a constant. S is now dependent upon it's dependent upon our data. It's dependent upon our sample. So we have a random variable here and a random variable here. That's the t distribution. I don't want to talk about the t distribution here because the t distribution doesn't have anything to do with the central limit theorem, but it does have to do with sample size, and so that's why I'm bringing it up. Please see my videos on the t distribution. They're important to note because there are some sticking points that a lot of students get hung up on. But for this demonstration, all I wanted to really point out to you is that what a large sample is saying. The large sample is basically giving us kind of a carte blanche road, an easy street, just because it's saying, hey, you're normally distributed, your frequency distributions of the sample means are normally distributed, and we have a good estimator, and so boom, we can use our z distributions to get probabilities and so forth. Okay, if we have a sample size that's less than 30, we may have point number 1, we don't have point number 2. Number 1 is really depending upon how your parent is distributed. But number 2 is really dependent on your sample size, strictly. And that's when you have to use your t distribution. Okay, and again, I talk about that. So that's pretty much all I wanted to say. I didn't really get a chance to perhaps say it as well on my first clip, but I'm trying to sort of maybe make up for it here. Please leave any comments. If you're still confused, perhaps I can make another video, perhaps with some examples. I don't particularly go into examples so much for these videos, only because there are so many other videos that do go into examples, and most of them are actually quite good. Some are not, but most of them are quite good. I'm trying to get into more of the behind the scenes, what's going on underneath, more of the theory kind of approach to assist you in understanding what's going on in the central limit theorem and with sample sizes and so forth. Anyway, hope to see you in the future. Have fun.